Hi guys, this is Math Made Easier with Delmi. Today I'm bringing to you an exciting topic which somehow difficult, but I'm making it so simple. Differential equation. Now, with differential equation, I want us to know about the types of differential equation, the definitions, and how to identify the various types. That's my main concern for today in today's lesson, how to identify them. Now, for every equation that has a derivative, it's a differential equation. It may have two or more or one derivative is a differential equation. All right, now let's look at some examples of differential equation. We have dy on dx equals 2x squared plus 4. Here we have dy on dx. Because of the dy on dx, it makes it a differential equation because dy on dx is a derivative. Clear? Here is another example. Okay, but note that here you see we have the derivative here, and we also have a derivative here. Note that the derivative can be written in this way as well, this way. Okay, whatever function that is being derived, you just need to introduce a prime, okay, based on the number of times it's being derived. Okay, so here the derivative is a first degree, so we have the first derivative here. So that's well. If it's a second degree, then it will be 2 double prime. Okay. All right. So what are the types of derivatives that we have? The types of differential equation. We have ordinary, partial, linear, nonlinear, homogeneous, and non-homogeneous. Now, to me, I concentrate mostly on the ordinary differential and partial differential because they are the main. For the rest, they are just classifications because they can be found in ordinary or partial. Okay, mostly in the ordinary differential, we can get a linear, non-linear, because ordinary can be linear, ordinary can be non-linear. It can as well be homogeneous or non-homogeneous. Okay, so here the mean you need to know that it's ordinary and partial differential equation. Okay, so in this video we'll look at how to identify the types of ordinary, how to identify the types as an ordinary and as well as a partial. In the subsequent video, we'll be looking at the linear and the linear, non-linear, and the rest. Okay, so ordinary differential equation, which is the ODE. Any differential equation with only one independent variable is an ordinary differential equation. So if we have a differential equation with only one independent variable, it becomes an ODE. Now let's look at some example. So here we have 5 different examples. A closer look at the examples, realize that the functions are being derived in terms of a single independent variable. Now, if you want to know what an independent variable is in a derivative, it's always the variable at the denominator. So if you are, for example, we have dy on dx, the x at the denominator becomes the independent variable. If we have dr on the theta, then the theta becomes an independent variable. So you can see from the example. So you see that the independent variables are the independent variables are just one, the one in each of the examples given. Clear? Good. That's how it's clear. Okay, so we look at partial differential equation, PDE. Now, if your differential equation has more than two independent variables, then it's a PDE. Sorry, more than one. So it means that it has two or more, okay? Two or more. Then it's a PDE. So some examples are, so here, the notes, as I've explained before, that as I've explained of independent variables. So you can see what independent variables are here, okay? So this, you find the definition of independent variable. Now we also realize that the independent variable affect or influence the dependent variable, okay? Yeah. So examples of PDE. Here we have an example, and you see, realize based on what I've explained earlier on that the independent variable here is small t, small letter t, and independent variable here is small letter x. So that means the function, that means that the function of capital T, the function of capital T is in terms of the function of capital T is in terms of t and x. So I hope it's sound good. So the t function is in terms of, so it means that this means that t function is in terms of small letter t and x. So now let's look at some examples in real life. Okay, some example in real life that involves ODE and PDE. For ODE, now the demand of a commodity, the demand of a good, it depends on the price of the commodity. Okay, so when you have two goods, either if you have two cloth, if you are going for a cloth, if you are going for a cloth, for a shirt, if the shirt you will go for a shirt which is of less, a shirt of cheaper cost, a shirt of cheaper cost has a higher demand than a shirt of higher cost. Anyway, we are not talking about relativity here, but in terms of two different shirts, but we are talking about relativity in terms of two different variables. Okay, two different variables which where one depends on the other. Okay, so here it's saying that the demand for a commodity, okay, it depends. The demand for a commodity depends. So here the demand for a commodity, it depends on the price of that commodity. Okay, so here the price is the only independent variable. So when the price changes, if it goes up, then the demand falls. If it goes down, then the demand rises. So that is in real life. That's the best example I can give. You can as well give other examples and let me know in the comments. Okay, so we have a PDE, and then PDE, you see that the PDE, there are lot of independent variables with relation to PDE, and that is energy put in, distance covered, and time taken. So three different independent variables that affect the rate. Okay, so that is for PDE. You must well add your comments in the comment section. Now, could you answer this? Could you answer this? ODE or PDE? Here goes the functions. I'm giving you some time to think through and pick the right answer. Well, I hope you've said this is PDE, this ODE, this is PDE, and this is ODE. And this brings us to the end of today's course, today's lesson. So tell me what you think about this lesson with your comments, and do not forget to like if you have not liked. Like the video, share, and subscribe if you have not subscribed. Thank you very much. See you in my next video.